Welcome, developers. So welcome to part 7, where we're going to send data to the simulator. But basically, I'm not going to go into much detail and show you a lot of different API calls, because we're just going to do a full replay. So in this lesson part, we're going into the recording software and then the replay software, and I'll show you what they do. Of course, all this shouldn't have been too much of a surprise, because I already said we were going to do this way. And of course, if you've been watching GitHub, then you've already seen all the necessary parts. So, without further ado, as it's being said, let's go into Visual Studio. Okay, let's start with a look at the recording software. If you've been following the updates on GitHub, then you know that we have in example 7-1, which is a program for recording an aircraft and recording movement. So let's take a look here in Visual Studio, and you see here our main function. It's a command line program, so it can look at the arguments that you pass. When you start it, it checks for a number of arguments. One that you can pass is duration. If you pass duration, it will take that as a number of milliseconds, I think, that it will record. That's for time-based recording. If you don't do that, run duration will be on 0, and then it will use or expects to use keyboard. Then, of course, you can provide names for the files for recording, and it then has a small sanity check. So if you haven't specified a run duration and you've not requested keyboard input, then it will give an error. Then it connects to the simulator. When connected, it can set up the key events. So it will register some events, which we'll talk about in a future part. And of course, then it will define the data areas for the aircraft info and for the aircraft position. Those are a bit more than just the aircraft info and aircraft position. Aircraft info has the full init position information in there also. So latitude, longitude, altitude, and pitch bank heading and speed, and of course an indicator of whether or not we're on ground. Position records more than just latitude, longitude, altitude, pitch bank heading. It also records speed in all 3 axes, and also speed increases, so acceleration. Then it will do a check, because if you have specified a run duration, that means it will immediately start recording. Now it will request once the information for the aircraft information, and then it starts the handle messages. So let's go up to handle messages. And that one is here. And handle messages has a bit of logic here about whether or not we have a deadline. It prints out some information. And of course, if it does have a deadline, it wants to know when we started, and then can add the duration to it. And then we have the well-known loop waiting for messages. Of course, we now also have some additional information about when we need to stop. It might either be because we've explicitly returned, but we can also stop because the deadline runs out. we go further, here is the actual loop that does the get next dispatch, which you can see here over on the right side. And then we have the exception messages, open, quit. And now, of course, the one that we're going to use, SimObject data. And there are basically two data areas, the aircraft info that we're going to then immediately write into a file, and the aircraft position, and it then expects the position data file to be open, and it will write in YAML format the output. Then there is also here a handling of event messages, and this is for the keys, the key presses that are going to be used to decide when to start recording if we're using keyboard based. So here you have that, and of course there's also a possibility to exit. So we're not going to go into details on that. That will be in another part. So that is actually all there is to it. We've already done everything in previous lessons about how to get the data. The data will be requested every second, which is why you'll see that the aircraft is actually going with pretty large intervals. We're not interested in making a full high fidelity playback. This is just a simple program. So let's leave it at that. Okay, so let's run this and go to the simulator and show what that does. Okay, so as you can see, we've started the simulator, and I've selected a nice small aircraft, the Diamond DA40, and let's put us on my favorite airport in the Netherlands, and then rather than going on the runway, let's pick a small parking. Okay, there you are. Sorry about the weather, but today wasn't that good weather, unfortunately, but nevertheless. Okay, we'll accept this, remove any red stuff, and just be ready to fly. And we're just going to do it like this. And let me put my feet on the rudder pedals and start the engine. It's a very light aircraft, so if I don't put on the brakes, it'll just immediately start rolling forward. Okay, now here you can see we have our flight recorder. So let's start the flight recorder and tell it to use keyboard input to determine when it needs to record something. So we'll start it. And you see it has already retrieved the information about the aircraft and wrote that in a small file, YAML formatted, so it's just readable text. And let's use the play button to start the record, like this. And then we'll just drive around a bit. So spool up a little bit and release the brakes, and then like that. Make a turn here to the left. And go further that way. We're not going to do anything special. Just make a small driving circuit here. And then return to our previous parking spot over there. I think this is enough. Okay. So you've seen me drive around, and the flight recorder has recorded that and made a nice file, also a YAML formatted file with not just position data, but also recorded speeds, and we can use that in playback. So we'll stop this bit and then stop also this session. So I can take another spot so we can look at what we recorded. Okay, back from the simulator. Now we've got our data, we've created 2 files that we can now use. So let's take a look at the software that does the replay. Okay, now that we've recorded 2 files, one file with information on the aircraft and its initial position, and a second file with the position and optionally speed and acceleration data in 1-second intervals. We now want a piece of software to play that back. So here we're going into the actual creation of the AI aircraft and how to send data to such an AI aircraft. So going here into Visual Studio, it starts just like the previous one. It uses a list of arguments. It's going to assume that the aircraft info has the name aircraft info YAML, but you can actually provide this as an argument. Then it will load that file and it will load the position data. And this is hard-coded in this version, and I'll probably clean that up later. It will then give you how many positions it has loaded. So that's a vector of position data. Then we connect to the simulator and we set up to the keys. Just like with the other program, we want to wait for a key that tells us when to start playing. But there are 3 possibilities here. We can replay with just the location data. We can replay with location data and speed. And we can also add everything, which is full, meaning that we don't just give it location and speed, but also acceleration. You see here that it has full and with speed as explicit options. So the default behavior will be to only use the location data. Okay, then of course we've loaded the initial position. Initial position includes an airspeed, but if we pass it the option stopped, then it will set that to 0. So that prevents you from having an aircraft that is immediately moving. If you don't want that, you can use that option. And then we can create our aircraft as we discussed. So this is for 2024. So we use the title and the livery, and we provide it with an ATC ID, and we provide it with a init position. Okay, we give it a request ID. We check if that succeeded, which is just if this call succeeds. And then we handle messages. So let's go up to the handle messages. Now, handle messages looks a bit like when we were recording, because we also have a start time, but now we need a moment when we start replaying. Initially, what we'll say is that if replay start is equal to start time, we're not replaying at the moment. Because we have a vector of positions, we're going to keep an index. Now, in this loop, we're going to first check whether or not we have an aircraft ID, meaning the aircraft has been created, and we are replaying, and we're not yet at the end of the replay vector. In that case, we check whether we have any entries that we need to send out, and if so, we will use set data on SimObject to actually send that out. And then, of course, we do want to record that. So if we do get any exception messages, we can match them up with what we just did. It uses a map for that. You can take a look in the code. Okay, let's go down. Here we have the usual wait loop, waiting for the messages coming in from the flight simulator. But of course, we don't want to wait only for those messages, because if we need to send out position data because we're replaying, we don't want to stop that if we're not getting any messages from the simulator. So we wait at most 100 milliseconds. Going down here, if we get any messages, then we can get an exception message, we can get an open message and a quit message. Now the first new one here is the assigned object ID. This one is created, and we can match it with the request ID of our create AI request. So if that's the one, then now we know this is the object ID of our newly created. There is a possibility that we've requested it to force it to be on ground. This was an idea I had because there are some reports that Flight Simulator 2024 may miscalculate the height of the aircraft with respect to its wheels, so the landing gear, but it's not going to do much for our demo. And of course, if we do have it, so we can now, because we now have the aircraft ID, we can do that send on ground. And then, of course, we have the event, which is used to start our replay or end the program. So actually, that is all there is. I think the most important thing here is the set data on SimObject, which is how you send data to the simulator. So let's now have a look and see what that does. And finally, let's see it all in action. So we're going back to the simulator, and this time we're going to do the replay. Okay, back in the flight simulator, and now we're at the next parking spot next to the one that we just used for the recording. Of course, as luck will have it, Flight Simulator has put another aircraft on that, but we're just going to ignore crashes and it'll spawn right in the middle of that one, but that doesn't really matter. For replay, I've used another aircraft, but let's just go and do it a bit like this, because it's going to make a drive around here and then turn to the left. And on the command line, you see we've picked the 7.3 example program, which will do the replaying, and we're going to tell it that it needs to start the aircraft and force it to have a 0 speed, because I noticed that it might use the wind and decide that it's actually moving. So let's ignore that and now start. Replaying, you see it's going to use position data with location only, and you'll see what the effect is of that. So let's just start the replay. You can see, by the way, there are extra wheels beneath that jet, and that's our aircraft. So let's see, and you see it moving a little bit, and in a moment it will start moving forward. Here it goes. Then the turn to the left, going over there, making a further turn to the left, driving a bit, and finally turning back onto the platform towards its start position. Okay, and you can see in the output from the replay app that it is finished. Next position due in 0 milliseconds, so done. Okay, fine. But you saw what that did. We had this aircraft just teleporting forward in small pieces of 1 second, which is, of course, not very realistic. And I said we had actually recorded a lot more data. There was also speed data in there. So, oh, sorry, use the key here. Now, add the speed data and see what that does for our aircraft. Okay, you see it's been recreated. Oh, this way. And let's start the replay. Okay, you can already see a little bit what is happening. It now actually is moving. And that is because we're telling the simulator that not just we gave it an updated position for the aircraft, but we also gave it a speed. You might wonder, okay, then if it has a speed, why doesn't it exactly move until the next spot in the recording? And that is because there is a bit of physics involved, and if you just give it a starting position, it will actually slow down because, of course, there is friction of the wheels on ground. But it looks a lot more like a real aircraft moving around. Probably the better way to do this is not to go in 1 second intervals, but use smaller intervals, something like 1/10 of a second. And I've actually seen some software that goes into pretty complicated computations to try to estimate where the aircraft should be, and then using not just the speed, but also changes in speed, and give it acceleration values. And if that actually measures well with where the aircraft should end up, it will just update speed and acceleration, but not location. And that can give you a very smooth result. But I mean, that'll take some physics and some mathematics to do it right. And we're not going to do that here. Okay, that's it for the replay. Okay, Welcome back. We did it, but as I said already, it didn't look very realistic. If you want to add a bit of realism, you need to have a higher, well, call it a frame rate or something like that. Once per second is not enough. Could have done that, but then you would get large files and didn't want to go there. 1 second just shows the principle, and that's good enough for now. But then speed and acceleration, yeah, that looked a lot better. So let's definitely use that then. And maybe you want to look in those math and physics parts where you can do a bit of prediction and then maybe even just say, I'm only going to update speed and acceleration, and actually location is good, but that means that you need to request data on location as well as setting it if it's not right. So there's a lot of stuff you can do there, and you can make it a lot more realistic, but for the demo, this was good enough. Then, of course, I did hint at this is what you go to if you want to build a multiplayer server. But if you want to do that, you need a lot of more work. You need to build that server component, and then you're going to deal with computers, multiple computers at different locations. Not everybody maybe is updating time on their computer locally automatically, and if they do, where do they get that time information? So you need to do something to make sure that everybody uses the same concept of now. And then, of course, because it's a network, and it might be milliseconds, it might be whole seconds, who knows? There is a delay. So you need to compensate for that. And then, of course, if you're going to build something that can be used by a lot of people, then you need to minimize those data transfers. So is that it? No, you can think of lots of other things that you can add. For example, you can say, well, if I see an aircraft of that other guy and he pushes his rudder to the right, then I want to see it move that way. If he extends his flaps, I want to see those flaps moving. If he stops and starts his motor, I want to see that. So there is a lot that you can add there that you need to take care of if you want to do this. We're not going into that. I just wanted to talk about it and why it's a lot bigger than just saying, let's add that. So, wrap up. This lesson, of course, was about putting data, but actually I used that as an excuse to show you the record and playback. And I think basics are already there for you now, so you can do quite a lot with this. Don't need to go much further, but of course there were those events. You heard me talk about capturing keys and responding to that. So we used events. We've already looked in one of the very first lessons at system events, but these are client events. So let's take that up in the next time. Okay, that's it for today. I do this just for the subs and likes. So if you want to leave one of those, please do. And for the rest, let's see you in the next one.